Alright, welcome back everyone. This is lecture number 10. Today we're going to be talking about some basic derivative rules that we will be using throughout the course. And this first one, it's called the product rule. And as the name suggests, it is the rule that we use when we're multiplying two functions and we're taking the derivative of that product. So in the previous section we learned, let me close this. In the previous section we learned so I was saying in the previous section we learned that the derivative of the sum of two functions is simply the sum of their derivatives, meaning that if you were doing if you were taking the derivative of f of x plus g of x, we learned last time that this is the same thing as taking the derivative of f, then adding it to the derivative of g of x. So this is what we did last time. Now, the rules for the derivative of the product and fractions or quotients of functions, it's not as simple as this. So we actually have a couple of rules that we have to do and we have to know before we could start taking those derivatives. So without further ado, let me give you the following theorem, which is simply referred to as the product rule. And this theorem says as following: the product of two differentiable functions f and g is itself differentiable. It's a pretty straightforward statement. However, now it's where it gets very nice. The derivative of f of g, f times g, so the derivative of f times g is the first function times the derivative of the second function plus the second function times the derivative of the first function. So that is to say, if you're taking the derivative with respect to x of f of x times g of x, then that is equal to the first times the derivative of the second plus the second times the derivative of the first. So this is how you kind of remember this. It's the first times the derivative of the second plus the second times the derivative of the first. I will prove this theorem in another video, but for now we're gonna do some examples. So example number one of using this product rule will be the following. So let's find the derivative of the function h of x when h of x equals 3x minus 2x squared times 5 plus 4x. Okay, so first of all, notice here that I do have the derivative of two functions. I have the derivative of this function times the derivative of this other function. So they're two completely different functions. They're being multiplied together. So if I wanted to find h prime of x, then I have to do the following. I have to do the derivative of the first times the derivative of the second plus the second times the derivative of the first. Well, the way that I like to do these problems is I like to say what is f of x, what is g of x, and then find out what their derivatives are independently, and then just put it all together. So let's say f of x is this first one, and let's say g of x is the second one. Then that means that f of x is 3x minus 2x squared, and it means that g of x is 5 plus 4x. And now their derivative, or the derivative of f prime of x by the power rule is going to be 3, the derivative of 3x by the power rule is just 3, minus, remember, bring that 2 down, multiply by the 2 in front, so 2 times 2, that's 4, x, and then you do 2 minus 1, which is 1, so it's 3 minus 4x to the first. Once again, this is by the power rule. And for this other one, the derivative of a constant, we know that's 0, plus, again, there's a 1 here, multiply, 1 times 4 is 4, and then x to the 0 is just 1, so this is just 4. So the derivative of g prime is 4. And again, this is from the rules that we learned last time. So this is the power rule in motion and the constant rule. Okay, but now we know what our f of x, g prime of x, and f prime of x are, and obviously g of x. So f of x hasn't changed, it's still 3x minus 2x squared, but now we know what g prime is. G prime is 4, so this is times 4, plus g of x, well, g of x is 5 plus 4x, times f prime of x, which is 3 minus 4x. And now the calculus step ended here. Once we find the derivative, the calculus step ended, and we have put everything together. Now what follows is just some basic algebra. So we have to distribute this 4, into the binomial here. So 3 times 4 is 12, so we have 12x minus 8x squared plus, and then here we have to again distribute this binomial, so we have 15 minus 20x plus 12x minus 12x squared. So if we simplify, if we combine like terms a little bit here, we have 15 minus 8x minus 12x squared. Notice here that there's some other terms that I can combine. I could combine this negative x squared with that negative 12x squared, and I can combine this 12x with this minus 8x, and we have I'm going to put the x squared term in the front, so it's going to be negative 20x squared plus 4x plus 15. So we have that the derivative of no, did I make a mistake here? Just make sure that I didn't make a mistake. Yep, I did make a mistake. This 4 times 4. 4 times 4 is not 12. 4 times 4 is 16. So this should be a minus 16 here, which means that this is a minus 16 here, which means that this is a 24, not a 20. There we go. That makes more sense. So minus 24x squared plus 4x plus 15 is our solution to this problem. So that just means that the derivative of h of x is negative 24x squared plus 4x plus 15. Now, for this particular problem, we did not need to use the product rule. We did not have to use the product rule. And the reason for that is because we could have distributed first and then taken the derivative. So we could have done the following. So sometimes, you could get away with not using the product rule, but a lot of times you cannot get away with just not using it. So for example, what we had here to start with was 3x minus 2x squared times 5 plus 4x. Instead of doing the product rule right away, you could have simplified this a little bit by distributing. So you could have multiplied this out, and this is gonna be 15x plus 12x, and then minus 10x squared minus 8x, and then you could have simplified this a little bit more. So let's see what we got. 15 minus 8, that will be 7. Whoa, where do I have this? 15x. Yeah. Let me make sure that I'm doing this right. Oh, I'm missing something. Hold up, my apologies. Let's do this again. Miss the x squared. So we have, let's do this slowly. 15x, 3x plus 4x, that's plus 12x squared, minus 2x squared times 5 is going to be minus 10x squared, and then minus 2x squared times 4x is going to be negative 8x cubed. This makes more sense. Huh? Now we could combine this like term, so I have minus 8x cubed in the front, plus 2x squared because of this, and then plus 15x. And now if you take the derivative of h, where h is this, then we could clearly see that we're going to have negative 8 times 3 because of the constant multiple rule. This is going to be negative 24x squared plus 2 times 2 is 4. You multiply this 2 by that 2, and then you minus 1, so plus 4x to the first, and then 15 times 1 is 15, and we get rid of the x, so plus 15. So we have indeed the same solution as before. Okay. Now, for this problem, we could have avoided the pro rule. For the next problem, for the next example, is going to illustrate why this rule is so useful. So in this next example, we actually cannot skip it. So let's find the derivative of y equals x e to the x. Remember last class, so recall, the derivative of y equals e to the x, so d dx, the derivative of this is equal to simply e to the x. So the derivative of the exponential is simply the exponential again. So here we actually do have to use the product rule. There's no other way of doing this. So if we apply the product rule here, what do we have? Well, we have the derivative of the first times the second plus the derivative of the second times the first. So again, I always suggest setting up your A, your G, and your F. This makes your life much easier, because then you can find their derivatives independently and combine them in the equation for the product rule. So I'm going to let f of x just be x, and that will force g of x to be e to the x. The derivative of f of x, since it's just an x here, is just 1. It's just a constant in the front. Remember, there's a 1 here. And the derivative of g prime of x, we just did here, this is going to be e to the x. So by the product rule, we have the derivative in terms of x of y is going to be equal to the derivative of the first times the second, well, the derivative of the second times the first, so it's going to be the first, which is x, and I should just write it down for you. It's going to be f of x times g prime of x plus g of x times f prime of x. These are times, not a minus. So we have f of x is equal to x, g prime of x is simply equal to e to the x, plus g of x, which is e to the x again, and f prime is just 1. So the derivative y prime is going to be equal to x e to the x plus e to the x. Okay, so here we could not avoid the actually using the product rule. It was unavoidable. There's nothing here to really simplify. There's no way of making that look nicer. Let's do one more. let's do one more. Let's find the derivative of the following. Y equals 2x times cosine of x minus 2 sine of x. Okay, so once again, what we really want to do is do the first times the derivative of the second plus second times the derivative of the first. Okay, so what is f and what is g? Again, I want to let f of x, and here we're going to have actually a third function, so I'm going to let f of x be 2x. I'm going to let g of x be cosine of x. One thing that I do need you to realize is this. Here, we use the product rule. We have two separate functions here being multiplied. We have 2x times cosine of x. Here, we don't need to use the product rule because this is just a constant multiple rule. This is a constant times a function. So we do not need to use the product rule on 2 times sine of x. It's unnecessary. But we do need it for the first part. So the derivative of y is going to be this sum right here will take care of this portion minus, the derivative of, I'll call it h of x. I'll call h of x is going to be equal to 2 times sine of x. Okay? So that's just this piece right here. And then this bigger piece corresponds to the 2x times cosine of x. Well, what is the derivative of f? Well, again, we have 2 times x. There's a 1 here, so you multiply by 1, so you get a 2, and then minus 1, that's just x to the 0 is 1, so we get the derivative of 2x is just 2. The derivative of g of x, well, the derivative of cosine, which I told you to memorize, is negative sine of x. So the derivative of cosine is negative sine of x. And here, since I'm going to be taking the derivative of this anyway, the derivative of h here, what I'm calling h, is 2 times the derivative of sine. Remember from the constant multiple rule, I could pull out this to the front and then just take the derivative in terms of x of sine of x. And that's just simply cosine. The derivative of sine is cosine. So we have 2 times cosine of x. And now we're ready to put this all together. So y prime equals the first, which is 2x, times the derivative of the second, which is g prime of x, which is minus sine of x, plus the second, which is cosine of x, times the derivative of the first, which is 2, and then minus h prime of x, which is 2 cosine of x, because that's just our h of x. So now what do we have here? Well, we could multiply this out. So this is negative sine of x times 2x is just negative 2x sine of x. And then 2 times cosine of x is just 2 cosine of x minus 2 cosine of x. We will have some cancellation here. So we have y prime equals negative 2x times sine of x. And then this cancels out. So the derivative of y is simply negative 2x times sine of x. Now, to summarize, the product rule says that if you have two differentiable functions or more, then their product is also differentiable. This is a rule that you have to memorize. So again, the rule is as follows. The derivative of f of x times g of x is equal to the first times the derivative of the second plus the second times the derivative of the first. Okay, that is all for this part of the video of the lecture.